All right, all right, all right. Let's go, guys. Here's Petra, community manager at Geeko. Today I'm going to be a moderator for React.js junior track. And we already have a speaker at our lobby right now. This is fantastic, spectacular. Erin Doyle. She is full stack developer at Theory and Principle. Full stack developer with the focus on front end. She loves JavaScript, doing a lot of React and Redux, and trying to write beautiful code. So what I'm going to do right now is to invite her to the stream, and we're ready to roll. Erin, how do you feel?
I'm feeling great, ready to do this.
Yes, 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 yes. I have no words to describe my reaction right now because that's what the only thing that I want to do is share a presentation and you rock, right?
Alrighty, I should be sharing.
Let's go.
There it is. Yep. All right. Well, I'll go ahead and get started then.
Sure.
So I am Erin Doyle, and I'm going to be sharing some tips and tricks with you today about auditing React apps for accessibility. So real quick, who am I? I am a full stack senior developer at Theory and Principle, and we do custom design and development for the legal and justice space. I'm also an egghead instructor. So I've got a course that is on developing accessible web apps with React that I highly recommend you check out. I am also an open source contributor, so you can check out my profile on GitHub. And you can follow me on Twitter at SunshinyDoyle. So real quick, just so we can all be on the same page, why is accessibility important? First and foremost, inclusion. So this infographic comes from the 2018 US Census, so it's a little old and it's only a small slice of our global population. But it gives us an example that there are millions of people using our websites that have a disability or difficulty of some sort. And many of these difficulties listed here make it especially hard for these people to use the web. And additionally, many people may not have a disability to begin with, but as we age, we develop these difficulties. In addition to that, we all at some point of time in our lives have temporary limitations or situational or environmental limitations. So for instance, say you've had an injury or surgery, you've broken your arm, your hand, your wrist, or you've got a cat in the way and you can't get to your mouse and you're going to be restricted to a keyboard. Perhaps you're sick or you're on medication that causes brain fogginess, making it really difficult to see the screen or to comprehend what you're looking at or to use fine motor movements using a mouse. Or perhaps you're in an environment, so you're on a mobile device outside where screen glare makes it hard to see, or you're trying to watch a video someplace that's really loud and you can't hear the sound, or you need to be really quiet and you can't turn the volume on. So these are cases where any of us at any point in time in our lives may have some sort of difficulty that makes it hard for us to use the web. In addition to that, it's the law. At least in the United States, we have two major laws that require all websites to be accessible to those with disabilities. There are many other similar laws in other countries around the world. As a result of these laws, there are thousands of lawsuits in the US alone each year against companies whose websites have been found to be inaccessible. So it's serious. We need to pay attention to it. And both of these laws in particular encourage using the WCAG, or Web Content Accessibility Guidelines version 2.0 level AA, as a guide on how to meet the regulations. So now that we know that accessibility is vitally important to everyone, how do we get there? So auditing tools and automation. Now, you don't have to be an expert in accessibility in order to get started in making your apps more accessible. There are a number of things that you can add to your projects and your workflow today to start improving the accessibilities of your apps immediately. These tools will do a lot of the heavy lifting for you, making it very easy to identify issues before they go to production. Additionally, taking a test-driven approach to accessibility can really help you incrementally learn more about potential issues and how to resolve them. Most of these tools that I'm going to talk about provide information and educational resources along with any of the findings or error findings that can help you learn more about the issue, what groups are impacted by it, how severely they're impacted, and how you can possibly go about fixing the issue. So keep in mind, automated tools can only catch a percentage of potential accessibility issues. Manual testing using the assistive technology devices and strategies used by our users is still crucial in identifying all accessibility issues or usability problems in your app. But using tools and automating what we can will give us a big boost. So if we all used these tools and fixed just what they identified alone, the web would be massively more accessible to our users. So there's no reason not to do it. So let's jump in. Starting with linting, there is a plugin for ESLint that will run a static analysis check for any potential accessibility issues in your code. If you're already running ESLint on your code, and you probably should be, this is a really easy way to start checking your code for accessibility issues. So to install, if you haven't installed ESLint already, you'll include that, and you'll include the plugin and save those to your development dependencies. You'll configure the plugin in your either ESLint.rc, ESLint.rc.json, or the ESLint config property in your package.json, wherever it is that you have ESLint configured. So to enable it, you'll add the plugin by adding JSX-A11Y to the plugins array. You can then either set specific rules from the supported rule set in the rules object, or you can enable all of the recommended rules at once by adding it to the extends array. And then if you want to use the strict rule set instead, you would just replace recommended there with strict. So to run ESLint for the command line, you can just add a script to your package.json file. And then from your terminal, you would run that command. So looking at the results, it lists all the files in which potential accessibility issues were detected. Under each file, it lists the specific errors in that file. And next to each error is the name of the rule that was violated. Another really cool benefit of using linting to check for accessibility issues is that most IDEs today have integrations with ESLint and can automatically show you any findings right in line with your code. This allows you to catch any potential errors immediately as you're writing the code. And then if you hover over the errant code, it'll show you exactly what the finding is. So if you take one of the errors that have been reported and look up the rule that was violated, you can get more information about it. The GitHub repo for the plugin has documentation on all of the rules it supports. So in the example I just showed you, I had files that were violating the label has associated control rule. If we look up that rule, we can see that for each rule in the documentation, it details what the pass and fail criteria is, so you can understand how the rule works, suggestions on how to resolve the issue, and links to the WCAG guidelines that are specifically violated by this issue. From there, you can learn more about how this specific issue impacts the accessibility for users. So now moving on to runtime tools. React acts as an analysis tool for auditing your app for accessibility issues at runtime, and then any findings are output to the Chrome DevTools console. React acts layers really nicely with the ESLint plugin, in that the plugin for ESLint can only audit the static code, but React acts looks at the rendered DOM. It can analyze the resulting DOM constantly as components are mounted, unmounted, and state changes. It can test for things like color contrast by being able to analyze the current foreground and background colors during all states of an element. You install it as a development dependency, just like the ESLint plugin. And to enable the tool, you'll need to initialize it early on in the code that starts up your app before the call to render the root of the app. You'll want to conditionally require React acts so that it's only running in non-production environments, as there is a bit of a performance impact when it runs. To initialize it, you'll just pass the imported acts function, the React and React DOM objects. And the third argument is the timing delay in milliseconds that React acts will wait to start analysis after detecting a component change. So once installed and enabled, React acts will run just as your app runs and outputs any findings to the DevTools console. This is the same page component that I showed the ESLint plugin had reported findings on. But you can see here that React acts is able to report even more findings of that same code now that it has the context of the entire DOM and its current state. Looking at what React acts outputs, It lists all found issues in order of severity of the impact to accessibility that the problem represents. And if you expand one of the findings, it shows you the errant source code. If you hover over the element listing here, it will highlight the element on the page, show you where it's at, and it will list more details about the problem. Finally, if you click on the link listed with the finding, just like the ESLint plugin repo, here you can go get more information about the issue. Listed here are examples of how to resolve the issue and make the element in question accessible. There is a section showing how severely accessibility is impacted for users, which specific disabilities are impacted, and which WCAG and Section 508 guidelines are violated. And then there's further detail explaining in what ways accessibility is impacted by this issue, which is really helpful in further understanding exactly how our code can impact people's ability to use our applications. Finally, there is a list of resources to learn even more through DQ University if desired. So let's talk about component libraries. Building a component library is a great way to gain efficiencies in creating accessible React apps. You can consolidate all of your UI widget components in one place. And by UI widget, I mean our basic building block UI elements, things such as form elements, text inputs, radio buttons, checkboxes, text areas, selects, interactive elements like buttons, links, tabs, nav bars, and then finally maybe more complex things such as dialogues, modals, menus, number steppers, accordions, carousels, and the list goes on. While of course there are still accessibility considerations once these building blocks are composed on a page, but the large bulk of potential accessibility problems lie in how these widgets are individually coded. So if you can write each of these widgets with accessibility in mind, then you now have a library of reusable components with accessibility baked in. You don't need to solve the same problems over and over again for each app you build. So the amount of issues you'll run into will be massively reduced. Storybook is a super useful tool for building a React component library. It provides a UI where you can browse the components in your library. And while doing so, you can view each component in isolation and interactively test the component by being able to change the props that are passed into it and see how it behaves, well before having to integrate it into an app. By being able to develop components in isolation outside the context of an app allows you to focus on building a component that can be reusable in various apps and testing various use cases ahead of time without having to worry about application-specific dependencies. So that when it's time to drop the component into your app, it's already been tested on its own. So Storybook has a CLI, making installation really simple. You'll run the init command of the Storybook CLI using npx inside an existing project's root directory. So a project you've already started, and you're just going to add this in. The command, when you run it, will install any required dependencies, set up the necessary scripts to run and build Storybook, add a default configuration, and add some boilerplate stories to get you started. Once that's done, you simply run npm run Storybook with, and then that'll start up a development server hosting your Storybook UI. So as I stated before, Storybook gives you the ability to test changing the props that get passed into a component, and then you can see how the state changes based on those values. And you can do that here in the controls panel for the component. Storybook also provides the ability to test your component using different viewport sizes and against different background colors. So here's where Storybook gets even more powerful. It supports a plugin system it calls add-ons. Most notably, there is an add-on for auditing the accessibility of components. So once it's installed and configured, it can audit a component for accessibility issues and display them in a panel. The add-on uses the same rules engine that React Axe uses called Axe Core. Here it shows you any violations, what rules were violated, a link to more information, and what WCAG and Section 508 guidelines were violated. So now let's talk about unit testing. We can also add accessibility testing to our unit tests, and that gives us an easy way to automate accessibility auditing. And we've got the flexibility to audit at any level of our code. We can go as low as an element or as high as a component representing an entire page of our app. This gives us a really great safety net for any regressions. So for all the reasons we normally write unit tests, we can apply that to accessibility as well. Jest Axe is a plugin to Jest that also uses the Axe core rules engine. That's the same rules engine we've already talked about used by React Axe in the Storybook accessibility plugin. If you're noticing a theme, in my opinion, the Axe core rules engine is the most trusted source for accessibility auditing at this time. So these tools that are built on top of it share a really thorough, dependable, and consistent foundation for accessibility auditing. If you're already using Jest for unit testing in your project, then all you'll need to do is install Jest Axe to your development dependencies. Otherwise, you'll need to install Jest, and you'll want to see the Jest docs for more detail on getting that configured. But assuming you're already running Jest, let's talk about how to add in Jest Axe. So you can use Jest Axe with whatever rendering library you wish, as long as you pass the Axe function, the HTML you wish to test. So here's an example using React DOM to render the component. Here in this test, we are rendering a component representing a login page. Now, this is the same login page we've already seen in some examples from the ESLint plugin and React Axe earlier. We are creating a div and then calling React DOM to render the component we want to test into that div. Then we pass the div element, which now contains our login page component as rendered HTML, to the Axe function. Finally, we call expect on the results with the matcher that Jest Axe provides us to have no violations. If a violation is found, then the test will fail and the violation will be output to the console. You can also use enzyme for rendering the component you wish to test. Here we use enzyme's mount function to render our component. Then we pass the result of enzyme's getDomNode function to Axe, because remember, we need to pass Axe HTML. Then the last step is the same no matter what rendering framework we use. We just test that the result from Axe has no violations. And finally, you can use React Testing Library. Here we're using React Testing Library's render function to render the component and destructuring the returned object to get the container. Then we can pass the container to the Axe function and once again expect that there are no violations. So here's what that output would look like for the test that we just saw the examples of. If a component being tested has a violation, Jest will output that the test failed. Jest Axe adds to the output for the failed test the HTML element where the violation occurred, what the violation was, a list of suggestions for fixing the issue, and finally a link to more information about the rule that was violated. So now let's talk about end-to-end testing. While a tool like React Axe can audit a page for accessibility at runtime, you have to be there manually testing your app to trigger the auditing and watching the DevTools console for findings as you go. This is great while you're developing, but it gets tedious as a method for repeatedly testing entire pages of your app at a time. Using end-to-end testing gives us the ability to automate the auditing of our rendered pages. With end-to-end testing, you can program interactions with the UI to fully exercise all possible states of your page's UI widgets and uncover any accessibility issues on the page. Just like with unit testing, this provides a great way to build a safety net to catch any regressions as you continue to develop. For end-to-end testing, we have some options. Most notably, we can use the Axe Core Rules Engine with both Selenium WebDriver and Cypress. So starting with Selenium WebDriver, there's a library available, Axe WebDriver.js, that provides WebDriver the ability to analyze the current page for accessibility issues. So you'll start by installing Selenium WebDriver if you haven't already, and see the link listed here for further details on setting up WebDriver and links to download any browser drivers you may need. Then install the library Axe WebDriver.js to your development dependencies. So Selenium WebDriver is run via script, and here is a really simple example test script. We only need to require Selenium WebDriver and the Axe WebDriver.js library. We build a WebDriver instance for Chrome in this example. Then we navigate to the page we want to test. In this case, it's that same old login page that we've used for a number of the other tools we've looked at so far. Once the page is loaded, we call the Axe builder we imported from the Axe WebDriver JS library. It requires we pass it the WebDriver instance, which we created initially. Then we can finally call the analyze function, which will audit the current page against the Axe core rules set and pass the results as the second argument to a provided callback function. All we're doing in this callback function is logging the results object so we can see what it looks like. So to run the test script, we need to run it with Node. And if you noticed in the previous slide, for this example, my script was named e2e-test.js. So that's the file we're running here with Node. Once the script starts, it will automatically open a window of the browser that we had specified in the test script. And then it'll navigate to the URL the script specified. After Axe WebDriver JS's analyze function is finished and returns its results, it passes them to the callback. And so the results object will be logged to the console as we specify in the test script. The first property we see in the results object is inapplicable items. These are all the rules that were found not to apply to the current page. There will likely be a lot of these. So keep scrolling and eventually you get to the incomplete items, which presumably would include any rules whose checks weren't able to be completed. And then there is a passes property listing all the rules that did apply to the page and passed. Then further down, you'll get to the details of the test engine, test environment, test runner, timestamp, tool options, and the URL being tested. And then finally is the violations property, containing any rules that the page violated. Each violation lists the description and detail about the rule, a URL where more information is available, the ID of the rule, how severe the violation impacts accessibility, references to the nodes and tags that violate the rule. But since these results are just being output using console.log, we only see array rather than a more useful representation of the value. But one can certainly customize how the results are reported using this results object to be more tailored to whatever your needs are. So now let's talk about Cypress. Cypress Axe is a package that adds commands to Cypress for testing the pages of your application for accessibility issues, once again using the Axe core rules engine. So you'll start by installing Cypress if you haven't already, and then the Cypress Axe package, both to your development dependencies. If this is your first time setting up Cypress, you'll want to add a command to open the Cypress app to your NPM scripts. Once you run that command, the Cypress app will automatically open in a browser window. And upon running the first time, it will install some directory scaffolding with some example files into your project. To continue setting up Cypress Axe, you'll need to open up the index.js file located in the Cypress support directory. You're going to want to add to it an import of Cypress Axe. Now, this makes the additional commands provided by Cypress Axe available to Cypress. So now we can look at an example test. First, we'll call the command to visit the page we want to test. Once again, my login page. That should be followed immediately by the command to inject Axe. This injects the Axe core runtime into the page, so it will be available to use for the auditing. Then we proceed to check the page for accessibility issues by calling the check A11Y command. To run the tests, you will go to the Cypress app and find the link for the test you wish to run. Here's the test we just looked at in the previous slide, login.spec.js. If you click on the link for the test, it will open a new window in the selected browser. Shown on the right will be the page under test, and shown on the left are the test results. Here you can see there were 5 accessibility violations detected, and each of them is listed. By clicking on one of the accessibility errors, it will highlight the elements on the page that contain that specific error. And additionally, it will log to the dev console more details about the error. So if we open up the DevTools console, we do indeed see more details logged about the error. Because Cypress Axe is using Axe core, just like the Axe WebDriver JS library, you'll notice that all the data points listed here are the same. So really, this gives us the flexibility to choose which end-to-end testing framework we prefer to work with without being restricted by our ability to test for accessibility, because both of them will give us the same results, which is pretty great. So now let's talk about continuous integration. This is really where a lot of these tools become the most powerful in helping us efficiently achieve and maintain the accessibility of our applications. We want to employ these tools I've covered so far all along the way as we're developing so that our code is accessible from the start. But continuous integration is where we can really implement that safety net to ensure that our application remains accessible. With every code change we make, we introduce the potential to break accessibility. The bigger our team is, or the more rapidly we develop, the easier for a code change to slip through that net. So employing some form of accessibility auditing in our continuous integration system can go a long way with helping that. Additionally, it can be used as a gate to prevent code changes that break accessibility from being able to be merged. Let me be clear again, as I stated at the very beginning, automated auditing tools will only catch a percentage of potential accessibility issues. It's no replacement for manual testing, which we do need to do fairly regularly. But being able to automate the auditing will still give us an immense benefit and provide an early warning system that can be run much more frequently than it's practical to perform manual testing. So out of the box with a continuous integration system of your choice, you have the ability to add any or all of the following to your pipeline. Linting using the ESLint plugin, unit testing using just Axe, or running end-to-end tests either using Selenium WebDriver or Cypress. So I'm going to show a quick example of how to run these tools with one of the CI systems. To keep things brief, I'm not going to show all of them, but the concepts are the same, so you should be able to recreate in whatever your CI system of choice is. So this example I'm going to show in a GitHub action. This is a YAML file stored at .github/workflows at the root of my project. This workflow will be triggered when any pushes or PRs are made to the master branch. And I've separated the workflow out into two jobs, which will run in parallel. There's the lint job, which will run the lint npm script I defined in my package.json file. This runs ESLint, which will include the ESLint JSX A11Y plugin, since I have that installed and configured in my ESLint config. And the second job is the unit test job. This will run the test-only npm script I've defined in my package.json file. This runs Jest, which will auto-detect my Jest test files and run the tests I've written using Jest Axe. The reason I have these broken up into two separate jobs is that I want to see any failures separately for each. If these tasks were run linearly, then if one fails, the job will exit before executing the following job. But I want to know if I have failures in both tasks rather than having to fix all failures in one and push changes before I can learn about whether I have failures in the next task. So here's what the results look like when this workflow runs on the project that we've been testing all throughout this presentation. So it shows that both the lint and unit test running jobs failed, as I expected them to. If we click on the failed run ESLint job, we see the output from the npm run lint script, which matches what we saw when I demonstrated using the ESLint plugin earlier. If we click on the failed run a unit test job, we see the output from the npm run test only script, which matches what we saw when I demonstrated using Just Axe earlier. So the point is, we can see how we're able to produce the same exact results we would get if we were running these tools locally, but we can offload that to our CI system to automate them for us. In addition to what you can do out of the box with your CI system of choice, there are plugins available for each of the major CI systems that we can leverage. So far, just about all of the tools we've talked about have been built upon the Axe Core Rules engine. But in the CI space, there are some other players. Most notably at this time are Lighthouse and Pally. Pretty much any of the CI tool systems can be set up to run either of these tools. You've probably heard of Lighthouse before, as it comes bundled with Chrome DevTools for performing a number of audits, such as performance, SEO, best practices, as well as accessibility. Well, it's also available here to use as either a CLI or CI tool. And once again, Axe shows up as Lighthouse uses Axe Core under the covers. Now, Pally is also a set of CLI and CI tools that can perform accessibility audits on a provided URL or file. It allows you to specify the test runner to use, and at this time comes with the options to use either HTML Code Sniffer or Axe Core. I'll show you some examples from each of the top CI systems, but this list is not exhaustive, and there are more plugins coming out all the time. So I urge you to do some research about what's out there for your system of choice. So the first thing we need to set up the Lighthouse CI, in the package.json for your project, you'll want to add a script to serve the production build of your app. I chose to use the serve package, but you can use whatever you want. Just make sure you've npm or yarn installed it as well. And then you're going to need to add a script named serve::lhci. It needs to be named that specifically. This is used by the Lighthouse CI to detect what it should run to start your server. And there are also options for letting Lighthouse serve static files in its own development server. So you can do whatever works best to fit your needs. Next, you'll need to create a file in the root of your project named lighthouserc.json. There are extensive options for configuring Lighthouse CI, but this was just the minimum needed to get up and running. So I encourage you to check their docs for more options. So the URL property takes an array of URLs I want Lighthouse to audit. Here I've just specified my login page, which we've been testing all along. Note it's at localhost and the port is specifically 5000 because that's what my server is going to host it at. Make sure you set the port to whatever your server will be using. The next property here I've got is single page application set to true because it is. And we've got a settings property here where I've specified that I only want Lighthouse to audit for accessibility issues. Because Lighthouse performs many categories of audits, I've added this just to restrict the results to the accessibility issues. So if you want to run Lighthouse with GitHub Actions, for instance, it's going to be very similar to the workflow I just showed you. You'll need to create, again, a YAML file in that GitHub workflow directory at the root of your project. Again, this workflow is triggered on push and PRs of the master branch. The workflow will do a checkout of the repo, set up node, and then install the Lighthouse Continuous Integration CLI. Then it will build the project. And finally, it runs Lighthouse, and it's going to use the configuration we defined in that lighthouserc.json file in our project. We could also pass flags into the LHCI auto run command in place of using the JSON config file, or you can do both. You can see here where I'm passing in the upload.target flag. If we want to use Lighthouse with Travis, it's pretty similar to the GitHub action. You'll create a YAML file named .travis.yaml at the root of your project. There is a before install step to install the Lighthouse Continuous Integration CLI. And then just like the GitHub action, we'll run the build of our app and then run Lighthouse. Then for Circle CI, again, the setup is not terribly different. You'll place a YAML file named config.yaml in a .circleci directory at the root of your project. And the necessary steps are exactly the same. We're going to check out the repo, install npm dependencies, build the app, install Lighthouse, and run Lighthouse. So it's really cool if you're using GitHub and you integrate your CI system with your repos there. There is a nice way to see the Lighthouse results in a much more readable and visual format than what you'd see just looking at the CI build log. So there's an official Lighthouse CI GitHub app that you'll need to install. Once you've got it installed and wired up with your CI system, you should start to see status checks for Lighthouse on your PRs and or commits, whichever you have your CI tool triggered by. A status check will show up for each URL you specified for Lighthouse to audit, as well as the overall rating for that URL. Since I only specified for Lighthouse to audit my login page, we only have one status check here. And then if you click on that details link by the status check, it will open up the Lighthouse report for that URL. It's pretty nice. If you are using Jenkins as your CI tool of choice, don't feel left out. It also has the ability to use Lighthouse.
Sorry guys, let me jump real quick. Erin, that's fantastic. We got 2 minutes left before our next speaker. So I propose to finish this speech and then we'll meet once again on Q&A session. So we have respect for everyone. And
sure, I can do a real quick wrap it up if you give me a couple more minutes.
Sure, just go with the flow.
Okay, thanks.
Thanks.
All right, so moving through Jenkins setup, You'll definitely want to check this out. There's a really cool option to set up a Lighthouse CI server that gives you the ability to have historical Lighthouse reports. You can check diffs, you can do charts and graphs. Very cool. There's also the Pally CI. There's some steps to configure it, but they're pretty straightforward. And then we've got, examples in all those same CI tools. It's all very similar, what you need to do. Travis, Circle CI, I'll point out, has a Pally CI orb you can use right here. And this is what the results look like if you're using Pally. Very similar. You're going to see a list of the errors found, details about what was wrong with each, and the specific element found with the error. Also want to point out that Netlify has its own plugin for using Pally. And you'll just need to check the docs on how to get that installed specifically for Netlify build. There's some configuration involved. And here's an examples of the results there. So if you're using Pally with Netlify and you've got it set to error, it will fail your build, or you can set it to warn and it'll just post warnings. And same thing here. You're going to see the list of accessibility issues found, description of each error, and the element that contains the error. So that wraps up all of the really cool tools I wanted to share with you today. I'll end here with a list of resource links to all the tools I talked about, so you can go check them out and add them to your dev workflow. You can get to these links where I posted the slides at erindoyle.dev/talks, and there will be a link to the React Global Summit 2020. So that's it for me. Thank you very much.
Amazing. Thank you too. I mean, guys, it's blowing my mind. I don't get how you get that information and you still code and you apply that information in real life. That's crazy. I'm super, super pumped about this conference because I'm learning so many new things, and I hope you guys in chat, all the viewers all around the world, feeling the same. Thank you very much, Erin.
Thank
that
you.
was impressive, very confident, very convincing, and hope to see you on Q&A session. And I will see, definitely.
All right, looking forward to it.
Nice.